But if I'm coming in the
Top
bottom,
feed, top lug, right?
if I've got a bottom feed and a top set of lugs, that's not opposite. Because the opposite side is going to be the one closest to the lugs. So opposite side is the one closest to the lugs. And so picture it like this. This is a harder install because of all the bends. So that's going to be table A. So if it's a top and a bottom in the same sentence, then that means you've got to come from the bottom and go all the way around to the top or vice versa. So the closest one to the lugs was what we call the opposite side, but it's closest to the lugs without any devices in between it and the panel. I guess you can look at it that way.
Now top lead, top of the lugs.
Yep, top lead, top lug would be the second two. Now that's what you have here. You've got to entering the opposite side there in the test question. So you're going to be under table B under B2. So table B is on the next page. Now, both of those tables deal with the number of wires per terminal. So if I'm running parallel sets and I've got more than one wire per terminal, in this case I've just got one set of feeders or one set of branch circuit conductors, one of the two. So I've got that first column there is going to be the one I'm dealing with. Or well, the first column's got numbers with, the first two columns are actually your wire sizes. But this is based on a wire size, so you've got a 3/0 conductor there in the test question. So you scroll down there on the side, on the rows, until you come to 3/0 and then slide over to the right until you're underneath the one wire per terminal. And you see it's 6.5 inches, but you got a little tiny letter up there next to it. And that takes you down the bottom, and the heading of the section that deals with the little letter A is actually number 2. And that tells you that if you have a removable lug or a lay-in type lug, and so like you know in your meter enclosure where you got that lug that you loosen up, the whole thing comes off, right? You just unhinge it, it just pulls right off. That's as easy as it gets. Because if I don't even have a lug to bend around and get underneath, I'm just going to be able to lay that conductor straight on there, put that lug on top of it, and it doesn't get any less hard on that conductor than period. So it provides a reduction of another 1/2 inch of the table value in that case, and so that's what you've got in it.
So the answer is
6 inches, not 6.5.
So number 1 is more bins. Number 2 is
That's
less
right,
bins.
absolutely. Yep.
That's what I know.
Yep.
Simplified.
Yeah.
Number 1 is what?
Number 1 is
More bins.
Number 1 is extra bins or mini bins. Yeah. The most bins. So the most bins, less bins, and very, very less bins if you're under the letter under table B. So even though table A is for wireways or gutters, it's going to be used for panels if it does not enter just directly opposite where those lugs are. All right. So the answer there is 6.5. 6 inches, which is number 3. Number 4. Number 4 is a good one in a couple different ways. First of all, a lot of y'all went to page 66, which is the residential table for ranges, and that's the first thing they like to see people do, because they started off the question or the list of appliances with a range. But because it's a commercial kitchen, that's actually on page it's 220.56 is the table. So 220.56 then be in the table. What I would do, guys, is I'd write commercial across the top of that one, and then the page to your left there, which is 220.55, I would write residential, so that you just kind of have a note there that prevents you from accidentally grabbing one for the other. Now, this is the first of the appliance tables, and it's also the same kind of mindset you have to have when we're dealing with our service calculations here in a bit, not today, but tomorrow. It's what we call the connected load and what we call the demand load, and those are two different pieces or two different numbers. The connected load is like that first example that I showed you of the 150 kVA generator, and then where the article says it's 115% of the nameplate or the output of the generator. The connected load is the nameplate rating, basically. So, for example, if you're talking about, in this case, the connected load would be whatever the value of this range, which would be 12,000 watts. Now, 12,000 watts on a range is never going to happen. It's just not. The manufacturer turned every single thing on in that range, even turned the little light on inside the oven part of it, and all the burners and warmers, everything on it, its highest position that it can possibly be turned on, and that's what that connected load is. It's just not going to happen. I mean, even at Thanksgiving, you got some simmering somewhere, not all of it being on at the same time, or if it is, it's not all at its top rated. If it is, if it's going to be for a fraction, well, it depends on how many kids you have in the house. Because in Mine's actually I can't say that it never happened because it has, but at any rate, you catch it pretty fast and the smart smoke alarms go off, so it's not for very long. And that connected load is that number, nameplate, sometimes we call it, sometimes you call it equipment rating or whatever. Now, the reality is that there's usually some demand factor, which is a multiplier, usually it can be a divider, but that demand factor is something that approximates where we guess the real actual demand on the conductors really will be, and so that's going to be a multiplier. In this case, the table has a graduated number that kind of goes down, so the more appliances that you add in there, the less likely that any of them by themselves individually are going to be at their highest, but as a group, even less so as a combined load on the service. So that factor then will take you to what we call the demand load, and that demand load is the calculated actual normal real world output that we'd expect to have on those conductors. We use that number then to size our wire and overcurrent protection devices, things of that nature. And these tables that deal with appliances are almost all the same way, where you've got a number of appliances on one row or column, and then you've got the factor there, which is a multiplier. Just put a decimal in front of it. So what we're going to do is add up the equipment rating of all the appliances given in the test questions. We got a 12, an 8, a 3, a 1.3 kW dish dryer. Add all those together, so that's the nameplate rating of all the appliances, and that comes to 24.3, which also happens to coincide with one of the answers, but that's not the answer. So 24.30 kW. We're going to multiply that times 4 of them would be 80%, and that gives you an answer that's 19.44. How many of you answered that as your answer? How many of you didn't answer it because you didn't get a chance? I'm just kidding. All right. Everybody that raised their hand, that's the wrong answer. You now have to stay after class for at least another hour. So the article number that controls that is, go back and read it real quick. See if you can find something that's labeled 220.56. It doesn't have a table in front of it. And read the last sentence. When you find that article, read the last sentence to yourself and see if that changes your answer.
Say that again, Rick, which one?
The actual article that has the same number on it. So you're going to go on a hunt now, and you're going to look for an article that's got.
Oh my God!
Really?
Can you believe that?
Yeah,
It's close to.
Cool. Yeah,
Real
it
close.
is. Real close.
156.
Yeah.
That's. I think that's why they love this question, because you have to even go to a different page to look. And it's so. There's a threshold with this table, guys, and that is that there's still a likelihood that 12 kW and that dryer at 8 kW might be on at the same time, and they might be awful close to their combined load. So because of that, there's a minimum threshold of the biggest two loads in that group can never be a number less than those two combined values, even with the table applied. So in other words, you still calculate it the way you did, which was adding them up, multiplying times 0.80, but you got a last step is make sure that those biggest two appliances in the service aren't a larger number, and if they are, then that's going to be your minimum number of 20,000 watts. So go back to that table real quick on page 67 and write yourself a note at the top of that sucker, never less than big two or two biggest or whatever you want to do to remind yourself.
I missed again where you said that was at. I didn't find it. It's not what it says. It's always
It's the article here that is
There it
the.
is right there. Yeah.
I had it highlighted too.
Well, you just don't see it coming. Is really
Say
the
it, never less than the
biggest two.
sum of two.
Two biggest, yeah. So it's just kind of like a safety valve. Whatever the biggest two appliances are, you don't have a number less than those two. So. But you see what I'm talking about with these tables, right?
Yeah.
And the point is that I've given you a list of them, and you don't have to worry and agonize over them, but you do have to go back and make sure that you don't where they're at, what they involve with, and some of them, like even the motor ones. I'll tell you, it was probably a year or so before I even realized one of them was labeled differently, and the label itself changes the way you look at it. And it's one of those. It's just unfortunately there's no school that teaches you everything about some of these tables. And the other thing, last thing I'll say about tables that they prey on, and it's not P-R-A-Y, or I guess they pray that you'll fall into their prey, P-R-E-Y. Is that a lot of times they'll break values. Sometimes that break value where the next row starts is included with the row above it. Sometimes it's the start of the row below it. There's no consistency. So, give a good example. There's two tables that they use it on a lot. First one is the more common GEC table. under 250.66 on page 115 in your book, code book. It's a table that I promise you'll have on the test, multiple times probably. It's a page 115. There's two tables in the grounding, page 115 and 125. It's really easy to kind of remember those two pages. But this one is based on an ungrounded service conductor, and so whatever the biggest wire in that group is what we play on. Excuse me, size it on. Pardon me. If you look at the way this thing is written, this silly thing, look on the 1, 2, 3, the fourth row down. It says over 3/0. So 3/0's the last thing in row 3. Now let me ask you, how many wires are there between 3/0 and over 3/0? Just one. The next one up is a 4/0, right? Why couldn't they have just written the 4/0 through 350? Wouldn't that make more sense? So just put a 4. Just cross that over 3/0. Just put 4/0 next in the margin, and then over 350, there's nothing but a 400 after that. So just put 400 as the start of that one, and then 700 is the next. There's not a
So
650.
number 3 is over, that's 400.
Yeah, it's 4/0 through. Oh, excuse me. 4/0 through 350, and then 400 through 600, and then 700 through. And they don't even make it 1100. They don't even make 1100 KC mill conductors. A 1250. So it's 1,000 and a 1250. So you tell me why that stops at 1100.
Parallel.
But how do you parallel it? I mean,
1100. I know.
yeah. I guess you could saw cut a 1250 in half and then glue it. I don't know. All right. So, but anyway, they'll give you a 4/0 or they'll give you a 3/0. 4/0 because it's not even listed specifically on the table. 3/0 because it's the end of one of them. And if you look on page 150. 152 real quick. The other one that they like to beat up on is a rooftop adder. And here the table's funky because it's the word above is sometimes hard to see, but really they give you 3.5 inches on a question that is has to do with wire capacity, and 3.5. If you look on that table, it's on page 152. It's the table to the right. The two tables on the page, in the right-hand column. And if you had a 3.5 inch install, you'll see that 3.5 inches is the end of row 2, and then the start of row